Welcome back to Unit 3.2. My name is Coach Perkins. If you have not met me yet, you can always stop by my room at any time. It doesn't matter if you've got myself, Coach Simpson, Ms. Grosjean, or any other Algebra 1 teacher. You can always stop by and ask questions. Unit 3.2 is talking about writing equations in both point-slope form and slope-intercept form, right? Both have their uses. So we're going to go over both of those examples, okay? So like I just said, we're going to learn how to write in two forms. First form being point-slope, and the second form being slope-intercept. You're probably used to seeing slope-intercept form. It's like your go-to answer anytime I say, well, what does the equation look like? And your favorite thing to say is y equals mx plus b, right? Point slope form you might not be as familiar with, but it also is very, very useful when it comes to writing these equations. Okay, so point slope form, is y minus y1 equals m times x minus x1. Okay, and so the point, right, it's very straightforward, point slope. The point is represented by x1 and y1, and then the m represents your slope. In both of these equations, m is going to be represented by slope, or slope is going to be represented by m. Slope-intercept form is y equals mx plus b. The slope is represented by m. Your b is your y-intercept. Okay, I know I just wrote intercept here, but it's your y-intercept. I also use m to represent how we're going to move, right? M, move. And b is where we're going to begin. Okay, so when it comes to graphing, that will be especially useful. Okay, but these are the two things we're going to refer to the entire time. Point slope form and slope intercept form, both very, very useful. And they tell you all you need to know in the names of them. Okay, so point slope form. To start in point slope form, what two pieces of information do you think we need? It's going to be the point and the slope, right? Point slope form, you need a point and a slope. Okay, where do we plug those in? Right? You plug in the y value from the point into y1 and the x value from the point into x1. And then we'll plug in our slope into m. We talked about how to solve for slope last lesson. So this lesson, we're going to take that and plug it into our equations. Okay? Slope-intercept form, the two pieces of information we need are the slope and a point, preferably the y-intercept. Okay, y-intercept. But if it's not the y-intercept, we'll talk about how to still write it in slope-intercept form if they don't give you the y-intercept. So on this one, you can plug in your y from a point in for y. M represents your slope, and the x represents your x from a point. B will also represent your y-intercept. Okay, your y-intercept is also part of your equation. Okay, so when you're writing an equation, when giving the slope and the y-intercept, okay, you're going to write down your point slope form. Okay, you're going to write the y-intercept as a coordinate point. Okay, and here's the handy dandy tip for anytime you have a y-intercept. Your y-intercept, x, is always 0. Okay, your y value will be whatever, but your x value will always be 0. Then you're going to substitute your slope in for m, and then your y-intercept in for x1 and y1. So, for example, if they give you the slope of -5, right? So m is equal to -5. And they give you the y-intercept of 2. Well, that point is really 0, 2. I'm simply going to plug that in to my formula, right? So my formula was y minus y1, well, my y1 is 2, so y minus 2 equals m, my slope, which is negative 5, okay, parentheses, x minus x1. My x1 is 0, so minus 0. Okay? You can also simplify, since it's minus 0, you don't have to actually put the 0. But this would be what the equation would technically be written as in point-slope form. Okay? For slope-intercept form, it's a little bit easier if they give you the slope and the intercept. So we're going to start with y equals mx plus b, right? Y equals mx plus b. And I'm just going to plug in what I know. Okay, my slope is negative 5, so instead of m, I'm going to plug in negative 5. And my y-intercept, which is just b, is 2. So instead of having b, I'm going to have plus 2. Easy peasy. Bada bing, bada boom. Okay? If you're given the slope and a point, okay? If you're just given a slope and a point, point slope is probably going to be your go-to, right? Point slope, slope point. Okay? We're going to start with our formula, right? Y minus y1 equals m times x minus x1. Okay? Our slope is 1/2, so instead of m, I'm going to plug in 1/2. And our point is 2, negative 3. So instead of minus x1, I'm going to plug in what my x1 was, which is 2. So x minus 2. And then instead of minus y1, I'm going to plug in what my y1 was. Y1 was, that's a mouthful. Okay, which was negative 3. Okay, this is where we talked about last time. This negative ends up getting distributed to this negative 3. So really my equation would be y plus 3 equals 1/2 x minus 2. Okay, and you'll notice in our point slope, okay, the sign that's in front of your point, right? So this is minus 2, is always opposite of what our value is in the point, right? Here we've got plus 3, but my value is actually negative 3. Okay, so that's a little shortcut you can use to avoid having to distribute this every time. It's just understanding that the symbol is always going to be opposite from the point that you use. Okay, for slope-intercept form, if they just give you the point and not the intercept, it's a little bit more work. Okay, we're still going to start with y equals mx plus b. Mx plus b. Okay, and I'm going to plug in what I know, right? I still know my slope is 1/2. They give me an x value of 2. Okay, and a y value of negative 3. Okay, so what is left to solve for? Well, b. I don't know what my b is. I don't know what my y-intercept is. So from there, I'm going to just solve for b. What is half of 2? Half of 2 is 1. So I've got 1 plus b equals negative 3. Okay, to get rid of this 1, I'll subtract 1. And I end up with b equals, not plus, b equals negative 4. Okay, once you have your b, you will go back up to our original equation, right, which we said was this. I'm going to just slide all of this over. Please move. It's so hard to grab. There we go. Okay, we can slide all this over. Okay, once you solve for b, you're going to go back up into your equation, take out the x and y, and rewrite it so that you have still y and x in there, but you've plugged in your m and your b. Okay, so our equation would really be y equals 1/2 x. You don't have to write plus negative 4. You could just write minus 4. Okay, so that would be my final equation for that. All right. So writing an equation, of a line when you're given 2 points. Okay, this goes back to our slope formula, right, which was y2 minus y1 over x2 minus x1. Okay, so we're going to use the slope formula to find a point, substitute in my slope and one of the points. It doesn't matter which point you use, it will still be correct. So let's identify our points. We've got x1, y1, and then x2 and y2. Okay, so my equation ends up being 15 minus 3 over negative 4 minus 2. Okay, 15 minus 3 gives me 12. 4 minus 2 gives me negative 6, which means my slope is negative 2. Okay, if we start with my point slope, right, y minus y1, not I, y1, equals mx minus x1. Okay, well, I just figured out my slope is negative 2. And then I can pick either of these 2 points, right? Preferably, for me, I'd probably pick the much smaller point in this case, which is 2, 3. So instead of x minus x1, my x1 is 2, so x minus 2. And then my y1 is 3, so y minus 3. And that would be my full equation in point-slope form. Okay, in slope-intercept form, okay, we have to do something similar. I have to find the slope using the slope formula, and then what we did the last time just a second ago. So we got to find my slope. Hey, what do we know? We figured out the slope, and the slope was negative 2, right? Because we just did it over here. Okay, so we take y equals mx plus b. Okay, and we plug in what we know. We just figured out my slope is negative 2. Okay, well, here I have an x value of 2, so I'm going to plug in 2. Okay, and I've got a y value of 3. Okay, from there, I'm going to go and solve this problem for b. Right, negative 2 times 2 is negative 4. So I got negative 4 plus b equals 3. To get rid of negative 4, we would add it to the other side. Okay, 3 plus 4 would give me 7. So I get b is equal to 7. Okay, then my final step would be to go back and plug that in. Y equals negative 2x plus 7. Okay, both of these examples would be correct equations for the given problem, just depending on what form we ask you to put it in. Okay, from a graph, it's pretty straightforward as well. We're going to find 2 good points, right, or pretty points, whatever you want to call them. Find our slope, aka our rise over run. Okay, and then you're just going to pick one of those points and plug it into the equation. Okay, so on this problem, I'd probably pick this point here, which is 0, 2. And the next pretty point is this one here, which is 1, negative 1. Okay, I'd find my slope using rise over run. So from this point to this point, I'm going to go down 1, 2, 3. So negative 3, because I went down, then over 1. So my slope ends up being negative 3. Okay, so if I'm going to type this equation, y minus y1 equals m times x minus x1. And I'm going to plug in what I know. Okay, I just figured out my slope is negative 3, so that becomes negative 3. And then I can pick either of these 2 points. It doesn't matter. Here I'll go with my y value of negative 1 and my x value of positive 1. Okay. Anytime you have minus a negative, that negative gets distributed, so it becomes plus 1. Okay. If they want you to write it in slope-intercept form, looks like that got cut off a little bit over here, but I can move it. That's fine. Okay. The key is finding your slope and then finding my y-intercept. Your y-intercept is where the line crosses your y-axis. In this problem, it crosses at 2. Okay. We find our slope the same way we did before, right? We go down 3 over 1, so my slope is -3. My y-intercept is 2. So therefore, my equation would be y equals -3x plus 2. Not -2x, -3x plus 2. All right? Okay, from a table, it's the same exact way, right? We're going to find our slope. Once we find our slope, we're going to plug in a point. Okay, on this one, my slope, my change in x goes -2. Then from here goes -6. Here goes +1, and then +3. Okay, and remember, slope is just a ratio, right? So we do our change in y, which is 1, over our change in x, which is -2, so -1/2. And it doesn't matter if it's -1/2 or -3/6. Those mean the same exact thing. They can be reduced. So my slope is actually -1/2. Okay, and I can pick any of these points to work from, right? So for me, I'll pick this point. Okay, you could pick the second point, the third point, doesn't matter. And I'll go y minus, okay, what was my y value? Was 2. Y minus 2 equals m, my slope, which was -1/2, so -1/2, parentheses, x minus x1, which was 7. Okay, slope-intercept form, we'll do the same exact thing. We find our slope. Hey, we did the magic slope. We just found over here. My slope was -1/2. Right, so y equals mx plus b. Okay, my slope was -1/2. Okay, my y value was 2. My x value was 7. Okay, now we've got to find my b value. Okay, well, half of 7 is 3.5, okay, which is really just 7/3. Not 7/3, 7/2. So you've got 2 equals -7/2 plus b. Okay, we can add that to both sides. Plus 7/2. Don't glitch out on me, computer. Plus 7/2. Because 2 is really 4/2. 4/2 plus 7/2 ends up with 11/2 equals b. So my equation for this problem ends up being y equals -1/2 x plus 11/2. Okay, we can just leave that as a fraction. You don't have to turn that into 5.5 or anything like that. Okay, once again, just to reiterate from a last class or last lesson, we've got Hoy-Vux. Okay, Hoy stands for horizontal, 0 slope, and y equals a number, right? Anytime it's horizontal, I have a slope of 0, and it's always y equals a number. Vux, once again, stands for vertical, undefined, and x equals. Okay, if it's a vertical line, has an undefined slope, and it's x equals a number. Okay, so for example here, if I have a slope of 0, okay, a slope of 0, Hoy means that it's going to be y equals just a number with no x value. And to figure out what that number is, I simply have to look at my y value of the point. Okay, my y value is 3, so therefore my equation is y equals 3. Here, If they tell me my slope is undefined, okay, if I have an undefined slope, that means I have a vertical line, which means it's just going to be x equals a number. To find the x value that it's going to equal, we look at the x value of the point. So my equation for that one ends up being x equals -4. Okay, so it's y equals and x equals for those equations. Those are special cases when we're talking about writing our slopes. Okay, a few more practices, right? If I want to write this in slope-intercept form, right? They give me a slope of -1/3 and a y-intercept of 0. Okay, so I can write the equation as y equals mx plus b. Okay, well, what they tell us, they told me my slope was -1/3, so I can replace that, -1/3. My b, right, my y-intercept is 0, okay, which I really don't even need. If it's ever plus 0, we can just get rid of that equation, right? So I would have y equals -1/3 x. Okay, if they give me these 2 points, right, and they are told to write it in point-slope form, first thing I got to do is find my slope. Right, to find my slope, I take y2 minus y1, so 4 minus 3, and put that over x2 minus x1, so 1 minus 2. 4 minus 3 gives me 1. 1 minus 2 gives me -1. So my slope ends up being -1. Okay, that being said, right, if I take y minus y1 equals m times x minus x1, we can plug in what we know. So my slope is -1. Okay, y1, you can pick either of these two, right? But if this is my point 1, this is my point 2, I might go with this. So y minus 3, because that's my y value, and then x minus x1, which is 2. Okay, looking at number 3, what kind of line do we have? We have a flat horizontal line, which means we have a slope of 0, which means my equation is going to be y equals a number, right? Hoi, out of hoi bucks, right? Horizontal. And you can tell where it goes through on the y-axis would be 3. Okay? And then last but not least, writing this in slope-intercept form, okay? So y equals mx plus b. Okay, my slope is 1/2. My x value would be -1. Let's do parentheses around that just to be safe. Okay, my y value is -2. Okay, we would have to solve for b. Half of -1 would be -1/2. Okay, -2 equals plus b. We would add 1/2 to -2, which would give me -3/2 as my b value. So my equation would end up being y equals 1/2 x minus 3/2. Okay, so that is, I believe that's our final one. Yeah, that's our final example for writing equations in both point-slope form and slope-intercept form. If you have questions on anything regarding those two concepts, feel free to reach out to either myself or your Algebra 1 teacher. We would love to help you guys out. We will have also the completed hand notes and blank notes available to go along with this. And other than that, I hope you guys have a wonderful day.